Hello all, welcome to the series of operating system. In this video, we will discuss about the shortest remaining timing first CPU scheduling algorithm and their example. Okay, so the SRTF algorithm is based on the criteria of burst timing because here we are focusing on the burst timing instead of arrival timing, and the mode is a preemption. Preemption means it will swap for some timing. That means for only some unit the process will be executed. Okay, now here in this example we have three processes P1, P2, P3, and their arrival as well as burst timings have been given. So based on this information we have to calculate the completion timing. Okay, then we have to calculate the turnaround timing, waiting timing, as well as the response time. So here we will use the Gantt chart again, right? Now we have to check initially whether there any process arrived in the ready queue, and as we know a ready queue is nothing but the RAM, right, where processes are arriving from 0th time. Okay, so that means initially we have to check at the 0 time is there any process arrived in the RAM. Yes, you can see P1 process is arrived in the RAM at the 0th time. Okay, so this is our Gantt chart. Fine. Now criteria is saying that consider the burst time, but in the ready state, that means in the ready queue or RAM, only one process is there, so there is no requirement to check the criteria. Directly you can execute P1 process. Okay, but how much timing for only one unit? For only one unit, because the correct mode is a preemption. That means for some time we are executing the processes. Okay, let us suppose why only one, why not two, why not three? Because at that time when we execute one process for 2 units, 3 units, or maybe 4 units, so at that time there could be chances of arriving new processes. That is why uh, generally we are executing processes for one unit. Okay, so that means still we have 8 unit remaining for the first process, because initially 9 unit was the total timing of the process P1, but here in this case we have executed for only one unit, so that means 9 minus 1, 8. So 8 units are remaining for process 1. Now again we need to check is there any process is arrived at the ready state while executing P1. Yes, you can see P2 process is arrived. Okay, that means we have to execute either P1 or P2. But now two processes are there. In that case we have to check the burst time. Which process is having shortest burst timing? So P2 process is having, you can see updated value for P1 is that is 8, and for P2 value is a 4. That means shortest is for P2. So that is why we will execute P2 for 1 unit, right? 1 plus 1, 2. That means now 3 units are remaining for P2 process. Is there any new process arrived? Yes. While executing P2, you can see at last P3 process is also arrived in the ready queue. That means in a ready queue, all three processes P1, P2, and P3. Right now, in this case, we have to consider again the burst timing. So burst timing for P1 is 8, updated is 8. For P2, updated is 3, and for P3 initially is a 9. Okay, so that means shortest again is there for the P2. So execute for 1 unit. So 2 will still left for the P2. Again check which is the shortest. Same, P2 is also again same case for this one. Now again 1 is remaining. So again you can execute a P2. Why P2? Why P2 again repeated here? Because the shortest timing in between these three processes are very less for P2 as compared to P1 as well as a P9, because P9 P3 is having 9 and P1 is having 8, and P2 is having 4, 3, 2, 1. So that is why till 5 we can execute P2 process. Okay, Now P2 process is completely executed. We have only two processes, that is P1 and P2, whose burst timings are 8 and 9. 8 and 9. So that means we will execute P1 process. Okay. So when we execute P1 process, again for 1 unit, if we execute P1 process for 1 unit, that means still 7 will remain with the P1 and 9 will with the 3. So again, P1 will be the smallest burst timing, remaining time for the P1. So that is why we will completely execute process P1 for remaining 8 units. So that means 5 plus 8 are nothing but the 13. So only one process is left in the ready state, that is nothing but the P3. So it will be executed for 9 units. So 13 plus 9 are the 23. So in this case, completion timing for P1, you can see P1, when P1 is completed, at this stage P1 is completed. So completion timing is a 3. Then P2's completion timing, you can see P2's completion timing is here 5. And at last we have executed P3, that is a 22. Now turnaround, based on this completion, easily turnaround timing we can calculate. So 13 minus 0, turnaround timing is nothing but the completion timing minus arrival timing. Completion timing is 13 minus 0, that is 13. Completion timing for P2 is 4 minus 1, that is uh, 5 minus arrival timing 1, that is 4. And completion timing for P3 is a 22 minus arrival timing is a 2, that is a 20. Okay, waiting timing is nothing but the turnaround timing minus the burst time. Turnaround timing is 13 minus original burst timing is a 9. So 13 minus 9 are nothing but the 4. Okay, now for second process, turnaround timing is 4 and burst timing is also 4. So 4 minus 4 are 0. And for last process, turnaround timing is a 20 and burst timing is a 9. So 20 minus 9 are 11. And lastly, response timing is there. So response time, that means initially when we are assigning CPU to that process. When initially we are assigning at the 0 timing, you can see initially we are assigning process 1 CPU to the process 1. So that timing minus arrival time. So initial timing for the process P1 is 0 minus arrival timing is 0. So response timing is also 0. When initially we are assigning CPU to the P2 process, you can see initial timing for this P2 is 1 minus arrival timing is also 1, that is a 0. But you can see for last process P3 process, initial timing is 13 minus arrival timings are 2, that is 11. So in this case, waiting timing and response timings are different. So calculate the average now. Average for this one, 20 plus 4, 20 plus 4, that is 27 plus 13, right? Sorry, here 20 plus 4, 24 plus 13. 24 plus 13 are nothing but the 37 divided by 3, because 3 values are there. So write your answer in comment box in a unit. And waiting timing, average waiting timing 11 plus 0 plus 4. So that means 15 divided by 3. So it's equal to how much unit? 5 units. Okay. So that is about the shortest remaining timing. In the comment box, I have given one example for your reference. You can solve and write your answer in the comment in the chat box. Okay. Thank you.